Hello, and welcome to today's webinar, Pulse Policy Secure Context-Based Network Segmentation. Before we begin, I would like to let everyone know that we'll be answering questions toward the end of today's presentation. To ask a question, just click on the question tab above the presentation console and type your question into the box. Please feel free to submit your questions at any time during today's presentation. Now, I would like to turn the floor over to Lisa Lorenzen, Principal Solutions Architect for Pulse Secure. Lisa?
Thanks, Craig. So good morning, good afternoon, good evening. Here today to talk with you about context-based network segmentation, the ability to do intelligent, dynamic, identity, and role-based access control in your network with Pulse Policy Secure. So there are a number of reasons that you might want to do network segmentation. The rise of BYOD means that end users are bringing in mobile devices and personal devices. Those may have access to basic resources like file sharing and other applications, but not have access to sensitive data. On the other hand, you do want to make the users as productive as possible while you're securing the assets and the environment itself. And one of the ways to do that is to do a compliance check and make sure that the device from which the end user is accessing the resource complies with the environment security policy. So all of these challenges can be met with Pulse Policy Secure and the ability to do identity-based secure access, whether that's admission control, network segmentation, local access, remote access, etc. Pulse Policy Secure offers mobility-ready secure access internally at admission and throughout your end user's connection session. The visibility provided enables you to do dynamic reporting to understand not only what IP address is accessing what resource, but what that IP address really represents. Who is that user? What's their role? What are they doing there? This enables better compliance and better compliance with audits of compliance. These context-aware NAC policies can be based on the user's role, the location, environmental information like the time of day, what part of the network they're coming from, the platform they're connecting from. All of these can be used to make a granular access decision around the end user and their personal device, their corporate asset on a wired or wireless network, coming in locally or from remote access. In addition, this end-to-end solution enables secure BYOD with automated onboarding, self-service enrollment, and the ability to leverage the environment you have rather than do a rip and replace to enable these new use cases. The Pulse Policy Secure delivers 4 primary benefits. The first is visibility. It's very hard to make security decisions without enough information. Who in your network needs access to what resources? What kind of traffic flows are passing through your network and what do they represent? The ability to associate a user with an access or a role with an access flow is huge for understanding what's actually going on, and it builds the foundations for the next benefits. First, one of those is increasing productivity. As we come in with our phones and our tablets, our personal devices, as well as our corporate assets, end users are accessing resources in more ways and from more locations than ever before. Being able to permit that access while securing the data and the network that they're connecting to and accessing means that people can do more work and be happier about it than ever before. To enable this framework, though, we really need the ability to demonstrate that we're protecting the data and controlling the network over which people are connected. This allows us to meet the regulatory compliance requirements of HIPAA, PCI, FERPA, FISMA, the whole alphabet soup. And all of this is delivered by a comprehensive access control policy that ensures secure access for users regardless of location, device, time of day. Even behavior in the network can be considered as a factor for ensuring that they have access to the resources they're authorized to access, but everything else in the environment is protected. Policy Secure offers 2 enforcement modes. In our previous webinar, which the recording is available on the Pulse Secure website, we covered admission control, the ability to identify a user when they touch the network and make a decision about whether to allow them onto the network. Today we're going to talk about network-based segmentation. Once that user has entered the network, what do we want to allow them to do? Network segmentation leverages the existing policy secure framework using a set of tools that patch together to apply access control end-to-end and to apply it based on a variety of factors that go into the access decision. So we start with the policy secure policy server. This is the brains of the operation, making decisions based on what type of device is coming into the network, who the user is that's accessing the device, and the status of the device itself. We can incorporate enforcement via these layer 3 firewall components. And today, that's done through the Juniper SRX firewall and the Palo Alto Networks firewall. But it doesn't end there. Once the user is on the network, has been authorized, we've checked to see that the device is compliant, we can also watch the behavior of that device so that if the device starts acting in an unexpected fashion, we can modify that access control decision. We can also extend this identity-based access control to remote access users as well as local users so that you have a seamless end-to-end solution with a consistent user experience regardless of how they connect to the network. Identity-enabled firewall enforcement basically uses the policy secure policy server to identify the user, identify the platform, optionally do a health check, and then make a role mapping based on all of that information. This can be done using either the Pulse client for automatic authentication, or for end devices that don't run the Pulse client, we have the option of a captive portal where users can authenticate directly. And the health checking is available in both of these use cases. There is also a third use case here for Microsoft Windows environments where you can leverage Microsoft's SP-Nego protocol to do a clientless authentication that does not require the user to authenticate to a captive portal. Regardless of how that authentication and host check happens, the next step is that the policy server provisions that user identity, role mapping, and associated IP address down to the firewall. This enables the firewall to take the existing stateful inspection capabilities and do an intelligent, dynamic access control decision based not only on the source IP address, but on the identity and the role of the user driving that traffic. The identity-based access control can be extended to both Juniper and Palo Alto Networks firewalls. For the Juniper integration, we also have the ability to do centralized policy provisioning, where the role-based access control policies can be configured centrally on the policy server and provisioned out to the Juniper firewall enforcers. This enables us to take advantage of the Juniper SRX application-based firewall capability. So you can do a user role-based decision on a Juniper firewall and manage policies down to the application level in addition to just the network traffic. The Juniper firewalls also support the establishment of an IPsec tunnel on demand from the authenticated Pulse client endpoint to the firewall itself. While this is not available for agentless users, it does give you, with the Pulse client, the ability to secure traffic inside of the network when it's passing through a less trusted segment of the internal network. So for example, if you have data that has to be controlled in an enclave or protected passing through different components of the network, this allows an end-to-end connection from the endpoint to the enforcement point that is dynamically provisioned on demand for IPsec enforcement. The Pulse client gives you all of these features in one place. It's a modular client that supports both SSL VPN and internal access. And the internal access control can be done through an 802.1x authentication at layer 2 for admission, or it can be done through a TLS-based layer 3 authentication in environments that don't have 802.1x enabled. Pulse client supports both machine and user authentication, and this can be integrated with Windows Credential Provider for a single sign-on to the user. One of the big benefits of a multifunction client is location awareness, and then the ability to migrate a session, so that when I connect in from my home office over the SSL VPN, and then I hibernate my laptop, bring it into the office, I don't have to re-authenticate. I have the ability for my session to migrate from the SSL VPN gateway to the NAC policy server. All of my access remains the same. Pulse client is built on open standards, such as 802.1x, Radius, IPsec, and the health checking standards from the Trusted Computing Group. This enables us to integrate with a variety of different technologies. For environments where you can't push down a client, guests, customers, contractors, etc., we have the option of a captive portal, where the policy server itself offers a web-based authentication and full integration with the host checking to do a compliance check on the endpoint. Speaking of host checking, we have a variety of compliance checks that we can apply to a variety of different operators. For the Mac OS X environment, we can check for hard drive encryption. We can look to make sure required security software such as antivirus, personal firewall, anti-spyware is present. We can do basic checks like processes, files, and ports, whether the ports are open or closed, whether the processes are running or not, etc. On Windows, we have all of that and more. We have integration with Windows patch checking. We can check for machine certificates on the device itself. There's the ability to do custom policy definitions. So if what we offer doesn't fully meet your needs, you have the ability to do some development of your own. Not listed here also is the host checking on Linux and Solaris, which is fairly basic, simply the process, file, and port set. What this gives us is the ability to do dynamic security enforcement. So when I connect to the network, I'm authenticated by the policy server, and then I try to send traffic through the firewall. And the firewall will permit or deny my traffic based on my role and what that role is mapped to in the resource access policy. If I then go to another location and connect in perhaps in Europe, perhaps in Asia, perhaps somewhere else in the US, I have the ability to connect in locally or through the remote access solution to resources in that region. And I also have the ability to access resources in my home region without a re-authentication. We leverage a functionality called Session Federation to enable this global federated deployment where you have single sign-on and a consistent user experience, not only for remote and local users, but also for traveling users that may be connecting into an office that's not their home base. Another function enabled by the network segmentation is the security automation, the ability to do coordinated threat control and identify unauthorized behavior that will then result in a modification of access control. So the way that dynamic security enforcement works for threat control is when an authenticated user connects to the network, the normal access control decision is made to allow or disallow that user. The initial access policy is applied, and so they're allowed to access the normal resources. Network sensors, such as profilers, SIMs, intrusion prevention systems, etc., are monitoring the network for unauthorized behavior. And when that behavior is detected, they can signal back to the policy server using open standards to identify the offending user. At that point, the policy server can modify the access control privileges so that a user may have restricted privileges or be disconnected from the network entirely. This means that you are protected against inadvertent unauthorized activity, as well as malicious activity, and against platforms that may be compromised with a zero-day infection or a sophisticated attack that's not detected by the normal access and compliance mechanisms. So what does this look like in practice? The workflow is pretty simple. When a user connects to the network, regardless of how they get on the network, eventually they will send traffic through one of these firewall enforcement points. This can be a Juniper SRX firewall or one of the Palo Alto Networks firewalls. So the user authenticates to the policy server. And let's say in this case, they were on vacation, they stuck their laptop in a drawer. If this has happened to me, I come back, my antivirus signatures aren't up to date, I don't want to bother updating, so I skip the update prompt. And then I try to connect to the corporate network. Bad Lisa, no biscuit. Policy Secure can detect that the user is uncompliant and assign me to a role with my access restricted so that I can only reach the resources that are required for remediation, and I can't get to protected or critical resources. Once I solve whatever the problem is, update my antivirus, run a scan, run the patch updates, then Policy Secure will reassign my policies so that I now have access to the normal resources for an authorized and compliant user. Optionally, That may involve a dynamic IPsec tunnel, or it may just involve direct access through the firewall to these resources. And of course, regardless of how I connect, I can only access the resources that are appropriate to my role, and I still don't have access to resources that are not authorized for my role in the network. So we can take this and obviously extend it to the layer 2 admission control as well for layered security. There may or may not be a gate when I enter the network, and so you could, if you also have 802.1x, you have defense in depth, where the 802.1x solution applies the first check, and then once I'm authenticated in that way, the firewall access is automatically provisioned. Enterprise-wide access control extends this granular role-based secure access to remote users as well as local users. In this case, let's say I'm coming in through the SSL VPN. This is my life. I work from home. I'm 80% travel. Most of my access to the corporate network is over our VPN. So I connect in. Again, in this case, the SSL VPN gateway can detect whether I'm compliant, quarantine me if needed, make sure that I'm authorized and compliant to access the resources over the VPN. Once I meet all the requirements, then full network access is granted to me via the Pulse VPN tunnel. And it's important here that this be a full IPsec tunnel and not some of our other remote access functions, such as WSAM or JSAM, or basic core access through the rewriter, through a web app, etc. As long as you have a Pulse VPN tunnel, you will need to authorize to the firewall to access these resources, and we can federate that authorization. So in this case, the SSL VPN gateway will publish user session information to the federation server. And that user session maps a user's IP address in the tunnel to their identity and to their role. This enables the policy server to consume that federated session, so that now, when I try to send traffic through the tunnel that then must cross a protecting firewall, we have the same process where the firewall is provisioned with an authentication table entry that enables it to make an access control decision. In this case, the access is only available for the Juniper firewall. So we do not yet have federation integration on the Palo Alto firewalls. And unfortunately, I see that that's an error in the slide. My apologies. In today's integration with Palo Alto, we do not yet have federation, but we do have it with the Juniper SRXs. Another advantage here is coordinated threat control. And with coordinated threat control, we have the ability to identify when an authorized endpoint is behaving in an unauthorized fashion. So you have an endpoint connecting to network resources. It's an authorized user, it's compliant, but it tries to do something that it isn't allowed to do. Once that happens, the sensors in the network, something will pick it up. A scanner, an IPS, a SIM, a profiler, etc. And it will signal to the policy server that the behavior is unauthorized. This is shared with the federation server, and so access control modifications can be applied both at the policy server gateway and even at the SSL VPN gateway if the user came in remotely. So the detection of unauthorized behavior can be federated throughout the network, and then Policy Secure and the SSL VPN gateway can identify the offending device and modify the device's access. So these firewall enforcement points may restrict the access in the network. And again, this applies both to the layer 3 segmentation, and it can also be pushed down as far as admission control with 802.1x, so that a user could be put into a different VLAN or even restricted from connecting to the network at all. Pulse Policy Secure offers a solution that's built on proven open technology. And the benefit of a multi-vendor solution is that we secure access via any 802.1x enabled switch or access point. We are a little more limited on the firewall side. We only work today with Juniper SRX firewalls and Palo Alto Networks firewalls. But we're working to expand our ecosystem and extend identity-based network segmentation to more firewall partner companies to extend our reach there. The context-aware policy enforcement for network segmentation means that you can apply these policies pretty much regardless of how the user connects. Remote access users, local users, wired and wireless connections locally, when they enter the network or as the session continues throughout the network. And we can apply this across the desktop as well as to mobile platforms. So this gives us a one-stop solution, end-to-end solution. And our onboarding and self-service guest access means that we're mobility ready and simple for an administrator to enable mobile solutions in their environment. Pulse Policy Secure offers a variety of benefits. Some of our strengths are this automation of our onboarding, the automation of incident response with the integration of coordinated threat control. We have the end-to-end solution that offers BYOD and NAC integration, seamless mobility, and the ability to integrate with a back-end MDM server to leverage Mobile Iron and AirWatch deployments for device classification. We offer a comprehensive access policy that gives us unified VPN and NAC policies. You have the ability to do single sign-on through session federation, so a remote access user has the same access and the same user experience as if they were sitting at their desk. And this allows us to do effective, secure access both on-premise and off-premise users. So our strong focus on security means that we've been securing mission-critical infrastructure for Policy Secure with our customers for almost a decade now. So Craig, do we have any questions?
We do. We have a few in the queue. First one, why only Juniper and Palo Alto firewalls?
That's a great question. The answer is that open standards are really valuable for interoperability, but in order to leverage them, they have to exist and they have to be adopted. So in the case of Policy Secure's enforcement, we can work with any vendor's 802.1x and radius capable network infrastructure, switches and wireless access points. And because 802.1x and radius are broadly adopted and very mature, basically any enterprise switch and any enterprise wireless is going to have that today. Unfortunately, there's no equivalent standard on the firewall side. So we don't have a standards-based mechanism to do this integration. And we've done the firewall enforcement based on direct integration with Juniper SRXs and with Palo Alto Networks over their API. There was an effort by the Trusted Computing Group to put forward a security automation standard that would enable more use cases like this. But unfortunately, we haven't seen a lot of adoption of that standard, so it's given us limited applicability. The Checkpoint firewall did implement that standard, and so we have had a couple of use cases where we were able to integrate with Checkpoint over the Trusted Computing Group standards. But primarily, I think going into the future, we're going to be relying on APIs. The only alternative there would be the Internet Engineering Task Force, the IETF, has a working group that's working on security automation and continuous monitoring. And so it's possible that one of these IETF work groups may come up with an open standard that would enable us to do this kind of integration and be more broadly adopted. So this would be a good area to watch that space and see what evolves there.
Great. Next question. Do you plan to increase the integration with Palo Alto to match what you do with Juniper?
Another good one. Yes, we hope to. So the original integration with Palo Alto was an out-of-the-box integration where Palo Alto could consume our Policy Secure logs and build their own interpretation of what user was associated with what IP address and what role. And the disadvantage to that is that it was really, because it was log-based, it wasn't very dynamic. So what we've done for this level of integration is we've actually written to the Palo Alto API so that now we can push to them a message when a user authenticates to establish that identity and role mapping to IP address. And we can also push to them a revocation of that mapping when the user disconnects. We are having conversations with Palo Alto about future integrations that would allow us to share more information with Palo Alto and also hopefully to consume more information from Palo Alto since they have a very rich detection and enforcement environment as well. So today, the integration is very simple, but we hope to expand that in 2016.
Great. Another one here in the queue for you, Lisa. About profiling, do you support other vendors?
Yes. So we have the ability to integrate profiling information from a company called Great Bay Software. They have a product called Beacon, and that product provides a back end of profiled information that we can leverage both for MAC-based authentication of non-802.1x endpoints at layer 2, and we can also leverage it for sensor event data for coordinated threat control. Another integration we have is with another profiling company called Rebasoft. Rebasoft also has a profiling solution, and we have very similar capabilities with them. Again, they build the back-end profile that we can leverage for MAC-based authentication and for coordinated threat control.
Great. Next one, any discussion with FortiGate, on API integration?
I don't know the answer to that off the top of my head. I would have to check with our product management team. I know that we've been looking at a variety of firewall vendors, and we do hope to expand our ecosystem, but I just don't know the status of that particular vendor. My apologies.
All right, and I think we actually have one more in the queue. Does this user identity processing slow down the firewall?
Ooh, definitely wouldn't want that. So the answer is generally no. In specific, the way that the user processing works with the Juniper SRX is that the user authentication table is held on the firewall, and the firewall associates traffic with the auth table to determine what role is associated with the traffic and what resources the traffic should be able to access. So when a Juniper firewall establishes a traffic session, there are really two phases to that. There is the setup of the session, and then there's everything else. So when a firewall receives a packet, it goes through what you can think of as the slow path, where it actually has to look up the source interface, the destination interface, map that to a set of policies, make a policy decision. And in that case, we're adding one small step to that policy decision, which is consulting the authentication table. So for the slow path, there is one small step, but it's not a very high resource consumption step. Once the session is established, for every packet after the first packet, there is no impact whatsoever because the session is already in the session table and it's going through the fast path, through the hardware-based decision tree. So for the Juniper SRX firewalls, there is very limited impact to the performance of the firewall. The only case where you might see a performance impact would be if you have a very high number of new sessions being stood up that are all enforced. In that case, again, it does add a very small amount of overhead, but the firewall functionality is very efficient to do those queries and to do the consultation of the auth table entry. On the Palo Alto side, we are feeding the user identity and role mapping to IP address to Palo Alto over their API. So all they have to do is consume that user identity and add it to their existing identity tables. So there, again, you should have minimal impact based on the user authentication step, the user identity mapping step, and it would really only be even noticeable in cases where you've got a huge number of new sessions being set up simultaneously.
Great, that's all the questions we have in the queue.
Great. Well, thanks, Craig. I look forward to talking with you on our next webinar where we'll do a little bit of a deeper dive into some of the visibility benefits of Policy Secure.
Fantastic. Thanks, everyone, for attending. Have a great day.
Thanks.